So class, today's lecture is about loan amortization schedule. What is amortization? Amortization is the process of spreading out a loan into series of fixed payment over the time. You will be paying off the loan's interest and the principal in different amount each month, although your total payments remains equal each period. Now this is a very important point. This point indicate that your total payments remains equal each period, and your total payments includes two things. The one is loan interest, the other thing is the payment. And in every payment, the amount of interest and the amount of principal varies. The second is, what is loan amortization schedule? An amortization schedule is a complete table of periodic loan payment showing the amount of principal as well as the amount of interest that comprise each payment until the loan is paid off at the end of its term. An amortization schedule is a table that shows each periodic loan payment that is owed. It may be monthly, it may be yearly, it may be quarterly, depends on the problem. Amortization table can help a lender keep a track of what they owe and when, as well as forecast the outstanding balance or interest at any point in the cycle. At the beginning of the loan, the interest costs are at their highest. Especially with long-term loans, the majority of each periodic payment is an interest expense, and you only pay off a small portion of the balance. In other words, you don't make much progress on the debt's principal repayment during the early years. And as time goes on, more and more of each payment goes toward your principal, and you pay proportionately less in the interest each month. Here, this is the loan amortization schedule, and you can see this, that first of all, payments are fixed each time period or each month or each year. The payment is fixed, and this payment includes two things: the interest and the repayment of principal. And here you can see the other thing, that the amount of principal is highest in the beginning years, and the repayment of principal is lower. And as you go more and more payment, then the interest is lesser and the repayment of principal is higher. Ending balance shows that how much principal you have already returned and how much principal is remaining. So here we go, we have problems. We have two problems in your course pack related to loan amortization schedule, 5-8 and 5-22. So we are going to make a loan amortization schedule for 5-8. You want to buy a car and your local bank will lend you $20,000. So 20,000 is your loan amount. The loan will be fully amortized over 5 years or the 60 month, and the nominal interest rate will be 12%. With the interest paid monthly. Now this is the important point. The interest paid monthly. So you will have to convert this 5 years into month, and this is annual interest. So convert it into monthly interest. What will be the monthly loan payment? PMT is required. Okay. So here we have the Excel sheet. Okay, class. So we have, first of all, write down the given data. We have present value of annuity, that is $20,000. This is the loan amount. Interest, here you can see that we have 12% interest is given, but the payment is on monthly basis, so we should divide it by 12. N is 5 years, so 5 multiplied by 12 because we have 12 month in a year, so N is 20. And what is required? PMT is required. Here we have the formula. Present value of annuity is given, and we are going to calculate PMT, whereas this is the formula of factor, right? Interest rate is 0.01, N is 60, and interest rate is 0.01. Okay, so in the next step we calculate factor is equal to, factor is 44.9 55. In the next step we have 20,000 divide by factor, so we get PMT so this is your payment, PMT. Okay, class. In the next step we are going to prepare loan amortization schedule. Okay, we have different columns. In column 1 we have time period, which is in months. Second column represent beginning amount of principal. Third column shows payment. Fourth column shows interest. Fifth shows repayment of interest, and the last column shows closing balance of principal. Okay. Okay, class. You can call this column as A, this is B, C, D, and E. Okay. Here we have month. Suppose we are going to calculate interest and repayment of principal for 5 months. 1, 2, 3, 4, 5. Okay. Then the beginning amount of principal, that is starting amount of principal, is 20,000. Here it is, present value. This is 20,000. Okay. And the payment, here we have already calculated payment. This one is the payment. So the payment is $444.88, and we know that this payment remains constant throughout the term. Now, interest. That is column C. Interest rate is 0.01. Interest is 0.01, and it should be applied on the beginning balance of principal each period. So multiply by column A. Here it is, that is 0.01 multiplied by 20,000. Okay. This is $200 is your interest. And how you can calculate column D, that is repayment of principal? Simply deduct the amount of interest in the total payment, that is P minus C. Here you can see that the payment is 444 minus C, the interest payment. And the last column is the closing balance of interest, E column. So you simply deduct the amount of D from A minus D. Okay, class. And on the next month, the closing balance of principal of the previous month will be the opening balance of the next month. So here it is F22. Similarly, you can calculate loan amortization. So this is loan amortization schedule just for 5 years. Okay. So now the next problem is 5-22. Jane sold her house on December 31st and took a 10,000 mortgage as a part of the payment. So 10,000 is your present value. The 10 years loan, 10 years mortgage has a 10% nominal interest rate, but it's called for semi-annual payment. So the payment is 2 times in a year. Okay. The requirement is same. You will have to prepare loan amortization schedule for 2 years. So I'm going to share the Excel sheet. This was A-20, A-22. Okay. Here we have present value 10 years. Interest is 0.05 because 10% interest is given and we have divided it by 2. N is 10 years into 2 payments in a year. PMT is required. So present value is 10. PMT, if we are going to calculate PMT, multiply by factor. So here it is the factor. We have, what is the interest payment? 5%. N is 20 now, and interest is 5%. Okay. In the next step, we calculate factor. So factor is 12.46%, 46.22. Now we divide 10,000 by factor 12.46221. So here's the PMT. That is $802.425 is your payment, right? So in the next step, we are going to prepare loan amortization schedule again. Okay. Here we have 10,000 as a beginning amount. The payment is 802. So 802.43. And the interest rate is, you can see the percentages, 0.05. So here we have 0.05. This one. 0.05 should be multiplied by beginning amount of the principal. So again, I'm going to calculate it for 5 semi-annual payments. Okay, here we have F24. That is the closing balance of the year 1 is the opening balance of next period. Here we have semi-annual payments. First payment, second, third, fourth, fifth payment. Okay, and this payments remains constant. This is the fixed payment, and here is the complete, no, not complete here, it is the loan amortization schedule for 5 semi-annual payments. Okay, class. Okay, so we have next problem. Next problem is future value of annuity 5-19. This is not related to loan amortization, but it is related to present value and future value of annuity. Your client is 40 years old. She wants to begin saving for retirement with the first payment to come 1 year from now. That is after 1 year. So the payment is after end of the period. Means we are talking about annuity ordinary. She can save 5,000 per year. Per year means this is your PMT. And you advise her to invest it in the stock market, which you expect to provide an average return of 9% in the future. So 9% is your interest rate. If she follows your advice, how much will she have? Means future value is required at the age of 65. So this 5,000 is your PMT, 9% is your interest, that is I. Future value of annuity is required. And what about N? What is N? So how much, now, how can we calculate N? N is equal to 65 minus 40. That is 25 years is the N. Why we have deducted 40 years from 65? Because she started saving after 40 years, not before 40 years. So we exclude that 40 years from the 65 years. Okay. So in the first part, the retirement age is 65. The second part, requirement age is 70. 5-19. This one. So we have PMT, that is 5,000. We have interest. Interest is 9%. And N is, as we have already discussed, 25 years. Okay, and what is required in A part? Future value of annuity is required, and here it is the formula of future value. Okay, PMT is 5,000 multiply by factor. So here it is the factor. Factoring interest is 9%, and time is N is 25 years. Again, interest is 9%. So we have factor 84.7. So in the last step, we simply multiply is equal to 5,000 multiplied by 84.70089. Okay, so this is your future value, $4,23,504. So she will get 4,23,000 when she retired after 25 years. And in the B part, just we have to change the N, and N is 30, because 70 years minus 40 years, so you get 70. You get 30. Okay, here it is. So the factor is 136.3075. 6,81,537 is the future value she will get after her retirement if she retired at the age of 70 years. Okay. In next part, part C, she expects to live 20 years if she retired at 65. and for 15 years if she retire at 70. Means if she retire at the age of 65, there are chances that she will live for 20 more years. Or if she retire at 70, then there's a chance that she will live 15 more year. If her investment continue to earn the same interest rate, that is 9%, how much will she be able to withdraw at the end of each year? At the end of each year means PMT is required after retirement at each retirement age. So, in simple words, PMT is required. Part C. When she retire after 65 years, she will get 4,23,000. So at that age, this will be her present value. We have this present value of annuity formula. Here it is. So present value will be 4,23,50, 4.45. Okay. Now PMT is required, and it is the factor. Factor is we have 9% interest. Now N is 20 years and interest is 0.09. So you can see the factor is 9.1285. Now we can take it to the other side of the equation. So 4,23,504.45 divided by factor, that is 9.18546 will be your PMT. So what is PMT? Here it is. 43,393 is your PMT. And part C has two calculations. Other is when if she retires at the age of 70, so it is expected that she will lives I think 15 years. Yes, 15 years. Okay, so rest of the factor remains same, 15 years. So the factor is 8.06. We have 8.06088. So here is the answer. When she retires at the age of, if she retires at the age of 70, then the present value will be 6,81,537.5. Okay. So here we have 6,81,537.5. Yes, class. The payment will be 84,548 if she retires at the age of 70, or if she retires at the age of 65, then the payment will be 46,393, because we have different present values in both cases. Here it is the present value and here it is the present value. So now we have another problem. The next one here, this is 5-21. Chrissy just won the lottery and she must choose among 3 award options. Now she has 3 options, and definitely she has just one best option, so she will choose the best option among these 3. She can elect to receive a lump sum payment of $61 million today, or to receive 10 end of the year payment of 9.5 million, or to receive 30 year of the end payments of $5.5 million. Requirement number 1, if she thinks she can earn 7% annually, what should be the best choice? Okay, class, she has uh, 3 options, and we have 3 different requirements with different interest rates: 7%, 8%, and 9%. Okay, so we are going to solve it. We have 3 options. Okay, and I'm going to do first part A, right? In part A, we have option 1, that is, we have straightforward $61 million. Okay, so this is the first option. In option 2, we have interest rate is 7%, payment time period is 10 years, payment is $9.5 million. Okay, so we just calculate present value of annuity, and then we compare all 3 options. We will select that option that has higher present value. So the formula of present value, here it is, the formula of present value. PMT is 9.5 multiplied by factor. Here we have a percentage of 7%, 0.07. Time period is 10 years, and the percentage is again 0.07. In the next step, we calculate factor, which is 7.02, and then the last step 0.95, that is payment. Now multiply by 7.023582. Okay, so it is the present value of option 2. Here is the present value of option A. Now we have option 3. The interest rate is same, that is 7%, and we have 30 years. Okay, but the PMT is just 5.5 million. So again, we have the same formula. Here we have payment of 5.5 and the interest is same, but the time period is 30 years. So the time period is 30 years. So here it is the factor and it should be multiplied by 5.5 million. In the next step, we have 5.5 multiply the factor. Factor is 12.40904. So the present value is 68.249. So which option is the best option? Option 3 is the best option. Why option 3 is the best option? Because it has higher present value. 61 million, 66.7 million and 68.2 million. Okay, this was the part A with 7% interest. Here, this is the part B with 8% interest. Same method is, now we have selected, and which option is the best option? So you can see option 2 is the best option if we have 8% interest. Here in part 1, part A, the interest rate was 7%. So the option 3 was the best. Here we have 8% interest, but option 2 is the best option. Rest of the procedure is same. And if we see the part C, when we have 9% interest, so the best option is option 1. Okay. So class, here it was 5-21 and we have last problem from the chapter. The last problem is this one, perpetuities. Perpetuities is a stream of equal payments. Stream means we have more than one payment of equal amount. The payment is equal, means that if the first payment is $10,000, the second is also 10,000, third is also 10,000. The interval is also fixed, means each time the time interval should be fixed. That is, if one payment is after 1 year, the second payment is also 1 year. The third payment will be also 1 year. But you know, the differentiating factor is continue forever. So perpetuity is the one which continues forever. You can see the formula. In this formula, we don't have any type of n. We don't have n because it is forever. It is not for 5 years, 10 years, 20 years, or even 100 years. So it is forever. So here's the problem, 5-16 from your course pack. The present value of perpetuity. What is the present value of a $100 perpetuity if the interest rate is 7%? So if the interest rate is 7% here, present value of perpetuity is equal to, we have $100 PMT should be divided by interest rate. So interest rate is 0.07. So what is the answer? Yes, any guesses? 1,428.571 $. The next part is if the interest rate double to 14, what would be the present value? So present value of annuity, perpetuities is equal to dollar 100 divide by 0.14. So is equal to $100 is equal to 714.285. Okay. So that's it. We have completed chapter 5. And in the next class, we will start risk and rate of returns. It is chapter 8. Take care, class.